100, 101, 102.
Corey, what are you doing?
I'm just trying to get tough, Kyle. I'm doing whatever I can.
Okay, tough like ruggedized lenses. Ruggedized lenses are a new generation of lenses that are emerging to meet harsh environments for new applications.
More and more systems are becoming automated, from agricultural equipment to robots working alongside workers in factories. And a lot of these emerging applications experience harsh environments outside of what machine vision lenses were typically used in. So they're exposed to shocks, vibrations, temperature swings, water spray, other contaminants in the air. And that is why these types of lenses are being created to maintain performance while being able to withstand whatever the world throws at them.
So why would a normal machine vision lens need ruggedization? Standard machine vision lenses are kind of designed to be a little bit flexible with applications. So they have adjustable iris settings, they have double focus mechanisms. It's good for flexibility, but when you need products for specifically niche environments or environments with actual extra harsh shock or vibration, you need some extra functionality there.
And even putting a lens onto a machine, loading it onto a truck, dropping that onto a factory floor, all that shock and vibration could ruin the calibration of something that was maybe set up ahead of time unless the lens is ruggedized.
Exactly.
The most basic kind of ruggedization is industrial ruggedization. And these instrumentation lenses are simplified. The mechanics are streamlined, there are less moving parts, and this makes the lens smaller, so it's more compact, lightweight, and even cost effective. An additional benefit of these is that there is increased protection of the F number or focus shifting as a result of shock and vibration. And these types of lenses are really good for a set and forget type of application. You're doing the same thing repeatedly with these lenses. You don't need the extra flexibility of a traditional lens, so you just set it up once and then let it do its thing without being thrown out of whack by shocks and vibration.
Yeah, and instrumentation means they're good for OEM applications and high volume production. So Stablized Ruggedization builds on industrial ruggedization. It starts with the simplified or streamlined mechanics, but it also contains different things like steel lock rings. You can see that right here for additional stability, as well as all the glass elements within the assembly are actually glued down. This prevents things like shock and vibration, which would normally cause decenter or tip and tilt within the actual assembly to cause things like pixel shift and resolution degradation. This prevents that.
Ingress protection ruggedization involves sealing a lens so that it becomes waterproof and it prevents solid contaminants from entering the assembly as well. So an Ingress protection lens, it is building again off of industrial ruggedization. This time O-rings are added to seal it. And so the Edmund Optics Ingress protected lenses are IPX7 and IPX9K rated to prevent contaminants from entering the assembly.
We've actually talked about athermal imaging lenses in the past. Athermal ruggedization protects lenses and other things from temperature changes. So whenever temperatures change, materials can either expand or contract. And there's two forms of athermalization. There's passive athermalization and there's active athermalization. Active is the form that requires some sort of compensation or feedback loop to compensate for defocus of the lens as it changes temperature, whereas passive athermalization really just relies on clever design and specific materials to adjust automatically without any kind of extra intervention. The athermal imaging lenses from Edmund Optics are passively athermalized and good for temperatures from -10 degrees Celsius to 50 degrees Celsius.
Yeah, so there's no motor in there making adjustments to parts. It's not actively athermalized, but it's just designed in a way that the natural expansion and contraction, the lens stays within specifications throughout that whole range.
Exactly.
And all these different types of ruggedization are bringing machine vision lenses into places they've never been able to go before. And Edmund Optics has standard off-the-shelf options for all these types of ruggedization we've been talking about. And we also do custom designs if you need a ruggedized lens tailored for your application. And as Kyle mentioned, we did a previous episode all about athermal lenses, so you can check out the link in the description if you want a deeper dive into that. And I think that's all we have for today, but thank you so much, and we'll catch you next time.